Hello guys, welcome to the course of TCP/IP. Today we are going to discuss the MPLS traffic engineering. Now, as we know guys, before this video we have discussed about the MPLS detailed study. So it is time to discuss about their applications. So traffic engineering, that is internet traffic engineering specifically, is one of the application of MPLS technology. So let's take the MPLS traffic engineering guys. Now, here very first we'll discuss the background, what the background of the traffic engineering, internet traffic engineering. Very first, what we can discuss about, let's say, traditional IP routing is based on the forwarding the traffic to the destination as quickly as possible. So, what is the purpose? What we can say in a traditional IP routing? The forwarding, let's say, forwarding of packets from one place to another package, it got too earlier, too quickly, or because we are using the source address and destination address, and we have set it all the things, that is routing table is available. On the basis of routing table we can decide that how to forward that particular packets. As a result, the routing protocols, there are two categories: static routing and dynamic routings. So specifically dynamic routings does these things. Find out the shortest path to the destination based on the cost of the link, also called as the matrix. That is the packet is forwarded. Okay, so what is the meaning of this sentence is, so packets are going to be forwarded with the help of, let's say, with the help of some kind of matrix, and that matrix can be a shortest path. That matrix can be a shortest path. So this is what the logic. Further, the IP packets are forwarded on the per hop basis. That is, every router, that is hop. Let's say if I have a B, and C. So here this is one hop, and that there is a the second hop. This hop forward the packet based on the destination IP address. So this is, let's say, destination IP address. Destination IP address. So this is at the target. This is at what the target. On the basis of this target address, the packets can be transferred. Now, the traditional IP routing does not take into account the available bandwidth of the link. So whatever the link is available from the A to B and B to C, it is not taken care with the help with in the case of the traditional IP routing. So this is what the problem. This case, this can cause the some link to be overutilized compared to the others. Let's say if we have a source A, let's say, and then any B, and let's say there are two intermediate nodes. Let's say there is a X and there is a Y. So here there are two paths available. There are two paths available. So we are not considering what kind of bandwidth is available with this path and this path. What we are considering only what we have target, where we have destination. For this destination, we are striving to that particular, reaching to that particular destination. We are not considering any bandwidth. We are not considering any other parameters to be to for the forwarding mechanism. This behavior in the traditional IP routing is called can be tackled using the policy based routing. What the policy based routing, where the admin is available and that admin can take the decision, and admin can set the configure that particular path or particular mechanism so that the packet can be transferred. However, it is required the policy to be implemented on every route along with the path to destination. But if our the network size is very high, that time the admin cannot configure each time. So it is better to have a policy. That policy can be implemented everywhere so that it can be a works like a dynamic kind of things. Okay, and this can result in a massive configuration on every router, because administrator, if it is done by the administrator, it is going to be a massive configuration. Okay, so here the MPLS traffic engineering solve the problem. This problem can be solved by the MPLS T, that is MPLS traffic engineering, where source based routing is applied to the traffic from the uh, head end router, that is source of MPLS traffic engineering tunnel. An explicitly defined path can be configured on the head end router through which the traffic for the particular LSPs must follow. That is, label switching packets must be followed. So what do you mean by now that these problems can be overcome by the traffic engineering? So what the traffic engineering? MPLS traffic engineering provide the efficient way of forwarding the traffic throughout the network. So in order to transfer the packets or traffic from the throughout the network, it is providing the efficient way. This is what the first definition we can say. Avoiding the overutilization and underutilization of the link. If any single link is overly utilized, overburdened, this can be overcome. And if somebody is lightly burdened, that can be also be what we can say, the solve the problem, that problem can be solved using this traffic engineering. The traffic engineering adapt to changing the bandwidth, so dynamically bandwidth changing can be possible. Traffic engineering takes into account the configured bandwidth of the links, so consideration of the bandwidth as a matrix for the IP packets, for the IP datagrams, is what the simplest definition of what we can say the traffic engineering, guys. So let's take another consideration of the traffic engineering. Moreover, we can say now here the requirements of the traffic engineering. Their first requirement is what the model. What kind of model? Because we are discussing the traffic engineering in the internet. So internet is what the very large network where the plenty of routes are available, plenty of devices are available, and out of available this kind of heterogeneity, we are maintaining the path, we are maintaining the way, we are maintaining the traffic across the network. So we have to consider the model. So here the model, in the model, traffic demand, because traffic demand can be traffic can be more, traffic demand can be more. What kind of expected offered load between the point in the network? Let's say A and B points are available. So what is the expected and offered load on this particular A and B? The network topology, what kind of how what type of topology is available, and what topology is configuration. That there can be different configurations like a connectivity capacity of the routers and the links. Somebody have the static routing, dynamic routing, OSP protocol, RIP protocol, any kind of configuration can be happen. Then internet routing algorithms also, the tunable rules for selecting a path for each flow. It can be dynamic also, it can be static also. The models can be considered over here. The second requirement, techniques for populating the models. What kind of measure to be taken? How it is going to be computing the traffic demand? Then determining the network topology and configuration. Then optimizing the routing parameters. If we are using the dynamic routers, routing algorithm, then we need to have, let's say, optimizing routing parameters. What parameters to be considered so that the processing capacity will be very less. Then the third requirement is what the analysis of the traffic demand. Then knowing how demand fluctuation over time, then understanding the traffic engineering implications. So these are the three requirements of the traffic engineering. So eight, we have not discussed any traffic engineering definition. What we have discussed only the background of traffic engineering and the requirement of traffic engineering. So let's move to the definition of the traffic engineering, guys. So it is what the one of the best application of the MPLS technology, like VPN and unicast services. The MPLS traffic engineering is what the best application of the MPLS. The traffic engineering refers to the process of selecting link state path chosen by the data traffic in order to balance the load on the various link routers and switches in the networks. What is the definition? It is what a kind of balancing technology for the load over the links, routers, or with the switches. This is most important in the network where the multiple parallel and alternative paths are available. And the goal of the traffic engineering is to facilitate the efficient and reliable IP network operation while simultaneously optimizing the resource utilization and the resource network performance. The network performance can be increased and the resource utilization can also be increased with the help of the traffic engineering. The aspect of network engineering dealing with the issues of performance evaluation and performance optimization of operational IP networks. The prior to MPLS traffic engineering, the technique like either IP or ITM depending on the protocol used between the pair of edge routers in the networks. So moreover, the simplest definition of the traffic engineering, internet traffic engineering is what defined that the aspect of internet network engineering dealing with the issues of performance evaluation and the performance optimization of operational IP networks. Traffic engineering encompass the application of the technology and scientific principle of the measurement, characterization, modeling, and control of the internet traffic. So what is the definition? In order to control the internet traffic, we required a mechanism so that the resources can be utilized effectively and network performance can be utilized properly. And that terminology is what the traffic engineering. And the traffic engineering definition came from the civil engineers, where consider a road where there are plenty of vehicles are available, how that vehicles can pass from one place to another place with the help of, there are signals, there are divergence, there are dividers. This kind of mechanism is what the traffic engineering. So ultimately, the flow of the data, flow of the packet over the internet can be tackled, can be handled with the help of traffic engineering. I hope, guys, the definition is clear to you now. There are some issues of the traffic engineering in the IP network. Destination-based routing. Destination-based routing is one of the issue, because which type of routing algorithm has been set by the destination, we don't know. That is the issue. Always use the shortest path. So we are not considering any alternative metrics to selection of the best path. We are considering what the shortest path, which was the maybe tedious task. So this is what the issue in the IP network. Then no traffic engineering. It means what? Some links are underutilized, or some links are maybe the overutilization. So underutilization and overutilization of the links can be tackled, can be solved. This problem can be solved with the help of the traffic engineering. Then what of the objectives of the traffic engineering, guys? So the objective number one, enhancing the performance of an operational network at both traffic and resource level are a major objective of the internet engineering. So traffic and the resource level management of what? To enhance this performance of the operational network at the both traffic and the resource level. And this is accomplished by the addressing traffic performance requirement while the utilizing the network economically and reliably. And the traffic oriented performance include the packet transfer delay, packet delay variation, packet loss, and throughput. This can also be tackled. They facilitate the reliable network operation. This also can be objective. Improve the survivability of the network path. So network path cannot be exhaust. It can be properly underutilized. It's supposed not to be underutilized or maybe overutilized. It is what the proper justification to that. The traffic engineering control functions generate the response at different times, scale to network events. This also be objective. And the packet level traffic control operation at a very fine level of temporal resolution, like traffic conditioning, shaping, and scheduling. What time to be sent, how to be sent, what to be sent. This called what the objectives of what the traffic engineering is. I hope the objectives are clear. Now let's take about the process of traffic engineering. The traffic engineering process it is a contiguous process which involve the four pillars, which involve the four entities, I can say. Very first entity is the policy formulation. Very first is what the policy formulation. What is available with the policy formulation? What the guidelines for the traffic management, traffic control, and operation of the network. So what's supposed to be the guidelines, how the traffic can be managed, how the traffic can be controlled, how the operation can be performed over the network. Everything is going to be set it over here in policy formulation. So ultimately, what kind of rules and guidelines are available, the manual to be prepared, and that is what the policy formulation. Second phase or second entity is what the data acquisition. Data acquisition. Once the policy formulation done, the practically statistics are gathered through the measurements. The measurements is done and the statistics are going to be collected. What kind of traffic patterns are, whether the traffic patterns is random, whether it is occasional, whether it is contiguous, what is the link utilization, what traffic trends, what are the packet loss drops statistics. Everything is going to be collected over here. So measure can be taken, the measurement can be taken, and the statistics can be collected for taking some decisions and on the basis of different parameters. So mathematical models can be used where the statisticals are unavailable and or it is supplements. Then the third phase, the third element is what? The analysis and characterization. Once the statistics has collected, the analysis and characterization done on the here, based on the workload derived from the measurement phase, the analysis can be done. Analysis on what the collected data, on the collected data. Once the analysis is done, it is going to be submitted to the performance and optimization. And what is going to happen over here? It is continual and interval process in the iterative process, continual or iterative process. Then here, what is going to happen? Traffic control, managing inflow to the network and mapping of traffic to the network resources, which topic to be mapped to the which resource, which topic which not to be managed, which not mapped to the which resource, that resource. This decision can be taken over here. Alternative network topology, adding links, increasing or decreasing links capacity. So it is going to be done at over here. Then controlling a local packet treatment like a queuing, scheduling, dropping policy. So here network performance can be optimized. And once the network performance can be optimized, it can be feedback to what if something is happened, something is happened wrong, it is not suitable and needs to be done. That to be done, it's supposed to be done. That's supposed not to be done. What to be do and what not to be do is going to be again conveyed, and once it is okay, then again the policy formulation can be take place. So again the rules are going to be modified, passes to the data acquisition, then analysis, then performance, and again it is going to be back to the policy formulation. Once everything is okay, on the basis of that the things is going to be on. So I hope guys this process is very important. Very first the policy formulation to be there, what and what supposed not to be, then data acquisition, collect the data, statistics, take the decision, that analysis. Once the decision okay, what to do. So performance optimization, how to do, what to do, that is done over here. And something goes wrong, go back, again set the policies. If something everything is okay, further proceed for the furthers. So this is what the continuous process of the traffic engineering, guys. I hope the traffic engineering is okay with you. An ultimate definition of the traffic engineering, guys, is what, how to manage the flow over the internet so that the devices, the resources are going to be utilized properly and the performance is going to be increased. So this is what the proper definition and all the process of the traffic engineering, guys. I hope it is okay with you. Thank you so much. Before this, what we have discussed about the MPLS technology, and further in the next video, what we are going to discuss, what are the advantages and disadvantages of the traffic engineering in terms of the MPLS technology.